Welcome to the Stormsurf video surf forecast for the week starting Sunday, September 18th. Looking at significant wave heights for the North Pacific Ocean, we see not a whole lot going on. A little bit of fetch here off of British Columbia generating, 10 or 12 foot seas. Another little area of fetch here trying to organize over in the northwestern Pacific, really doing nothing. And Typhoon Malachus approaching southern Japan with some pretty good winds associated with it. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, help direct their track. We're looking for a dip in the jet. Now, unlike the southern hemisphere where the dip actually went to the north, in the northern hemisphere, we're looking for a dip going to the south. Sort of like this, but more so and more pronounced. So this little, I guess we'll call it a trough, would support low pressure here in the Gulf. But notice, the jet, for the most part, is running on about the 42 north latitude line, going flat across the Pacific. That's what's considered a zonal flow, but a little bit of a split here over the date line. Another little trough, maybe right here off of Kamchatka. This would help support some formation of gale. That is, you get a counterclockwise circulation there aloft and down at the surface. That is the hallmark of low pressure. Low pressure, of course, generates winds. Winds generate seas. Seas, as they radiate away from the fetch area, generate swell. And swell, of course, produces surf when it hits your coast. So we have a little trough here. And the same sort of deal trying to go on here, but both are pretty weak. Zonal flows generally don't support gale formation very well. Let's take a look into the future. We'll roll this out. We're into Monday night. Notice winds pick up pretty strong. What is that, 170, 180 knots? But again, still zonal, and whatever trough there is up here in the Bering Sea, and then whatever was, here's the split thing that was going on over the dateline. Now it's in the Gulf of Alaska doing nothing. We get into Wednesday. We notice just a tiny little trough here, but most of the energy is all up in the Gulf of Alaska. And then the energy starts fading here on the dateline. And again, the zonal flow. I mean, this isn't a bad thing. We have, good, solid, cohesive jet stream flow, no major split. A little bit of a gentle trough trying to develop here over the dateline on Friday, and we'll see if it goes anywhere. And yeah, there you go. I mean, that is a trough, but you just need stronger winds. You need 150 knot winds, really, 140 knot, at least get into the purples here. And that's when we start getting a little bit more interested. And then this trough starts pinching off. Notice it's getting very steep into Sunday. And here we are at 180 hours out, just a pinch trough, not a lot of wind supporting it. Then things kind of fall apart over here in the West Pacific. So overall, not a whole lot suggested for the greater North Pacific. If anything, the Bering Sea is where all the action would be. Let's go take a look down at the surface. And here we go. Surface level pressure, surface level winds. High pressure kind of dominating. 1032 millibars right here. Ridging south into the U.S. West Coast. A little bit of fetch here off of Northern California, but near to the coast, pretty light winds. A new tropical system, Tropical Storm Payne here, south of Cabo San Lucas. Not expected to do a whole lot. Here's Malachus, heading northeast, expected to go inland over Japan. And then here's our developing low off of Kamchatka. We saw the trough there. Here's another area of low pressure. We saw the trough there in the jet stream. Sure enough, the surface is doing exactly what one would expect. This is to be where all the action is, but notice the Aleutians right here, just cutting off any swell energy. We'll just roll this out. See, actually, not even that much fetch up here, and all of it in the Bering Sea. Malachus moving over Japan, and Payne heading north, but very weak, drifting into central Baja on Tuesday or so. Malachus gets sheared by the high mountains of Japan, nothing left of it, and then a little bit of energy trying to get organized, but notice all the winds just pushing up into Alaska. No swell expected from that of any consequence. And we just roll out. We're into Thursday, and generally we have low pressure, but there's just no energy in the pattern, and then here comes high pressure starting building in on the weekend, next weekend. And we roll this out. We're into, here we go, a week out, little tiny low, finally organizing over the dateline. Not great jet stream support from what we saw, and just generally a lackadaisical pattern. Let's go take a look at the effect of these winds on the ocean surface. So here we go, significant wave heights for the North Pacific Ocean, and the current image, not a whole lot going on. We'll just roll this out, and as you see, we're looking for something pretty much the 30-foot seas, some indication of purple. That's when we start getting interested. We're not seeing it. All this fetch here just pushing right up into Alaska on Thursday, Friday, and then basically just a kind of anemic pattern. We get into 180 hours out and still no seas of interest. We know there's low pressure here, but we also know there's no jet stream support, so we don't expect anything from that. So, kind of not encouraging for the next week. Now, there is swell actually hitting Northern California and Central California right now. Quick review. Gale developed off of Kamchatka almost a week ago on Monday. Roll this out. Seas 28 foot pushing to the date line. You go, oh, that looks pretty good, but remember, it's 2,600 miles away from California, not as far away from Hawaii. Most of the energy, though, is aimed a little bit east of the islands. Then this system moved into the Gulf or the Western Gulf on Wednesday, 23, 24 foot seas, something like that, then petered out. So it really never got to even within 1,500 nautical miles of the coast. A lot of swell decay in the process. Hawaii ended up with a good little pulse of swell. When was that? On Saturday, I believe it was. Maybe 7-foot Hawaiian, 10, 12 foot, maybe some bigger faces. A little warbly, a little weird. And the swell currently hitting California, not particularly impressive. Let's say we'll give it head high or so in exposed breaks in northern San Francisco area. And a little bit more size expected for Monday, and then that's pretty much it. It'll die out, and after that, not a whole lot going on based on what we saw in the charts. But all hope is not lost. Summer has not given up completely. Under New Zealand, also a week ago, a gale started developing under New Zealand, 28-foot seas. That's not much. That is not even anything that we'd even look at. Now, Hawaii, Tahiti certainly would get surf from that. But what happened is it sort of reorganized on Wednesday, a little patch of 30-foot seas, and then reorganized again, got into the, 37-foot seas there on Wednesday night, and drifting a little bit to the northeast with nearly 40-foot seas on Thursday. And then, but notice, most of the track was to the east. The good news about that is this area right in here was actually unshadowed relative to California. Southern California expected to get a pretty nice little pulse of southern I will call it sideband swell, though it's pushing a bit up that way. But you really want the gale and everything pushing to the northeast. And this, as you can see by looking at the track, even in reverse, it was pretty much almost west to east over its lifespan, other than that little push right in here. Still, sideband swell expected for mainly Southern California. Northern California, you get something out of it. And this, we're talking later in the coming week into the weekend. So even though the North Pacific is sort of taking a little break, Southern Hemi energy still. So a little bit, best of both worlds. First we get a little pulse of north, now we'll get a little pulse of south. So, but beyond that, not a whole lot expected. Let's go take a look at the long-term picture. As usual, we'll talk first about the MJO, Madden-Julian oscillation. This system, when it's in the active phase, this pattern, if you will, typically goes 3 or 4 weeks on, 3 or 4 weeks off, travels west to east across the equatorial Pacific. When it's in the active state, helps supports fuel to the jet stream, which therefore helps to create storm formation, more so in the North Pacific in winter months, but also can have a positive influence on the southern hemisphere in summer months relative to the northern hemisphere. So let's get into the details. First off, we want to look for the active phase of the MJO. Typically where you look for that, this is New Guinea here. The date line is right here. We're on the equator in the West Pacific. We're only interested in the area from 135 east to about 170 west, 5 degrees north and south of the equator. Draw a little box here. We call that the Kelvin wave generation area. That's where the active phase of the MJO seems to have its largest influence. That's where, if it's in the active state, it helps to promote the formation of Kelvin waves, which is a whole nother story, but Kelvin waves during El Nino years, or at least help fuel the jet stream, the North Pacific jet stream, in winter months. So what we're looking for, if we look at actual wind speeds, this is from buoys that are an array of buoys strung across the equator, the whole way across the Pacific. East winds dominate, trades, and pretty strong here in the Kelvin wave generation area. This is anomalies, this chart here, differences normal for this time of year, and we see east anomalies in the Kelvin wave generation area. That is not good. That's suggestive of the inactive phase of the MJO. So that might help explain why the North Pacific is going to sleep right now, because these easterly winds just started developing about 3 days ago, and that seems to coincide almost perfectly with the shutdown in swell production in the North Pacific. Let's go look at some more details, other models, and suggestions of what's going on in this area. Here's another way to look at it. Zonal wind anomalies up at 850 millibars. That's about 4,400 feet up in the air, but that's a pretty good proxy for what's going on down at the ocean surface. Kelvin wave, and this is just 5 degrees north and south of the equator, and this is the Kelvin wave generation area, really basically from here down to here. Just go right down the chart. This is past history, so we had a little bit of east anomalies. The blues are east anomalies. If you see yellows, that's west anomalies. But look at here. Here's current time. Here's what's been going on for the past, 5 days, we'll say. Major easterly anomalies. Certainly looks like a pulse of the inactive phase of the MJO. The good news is we're through the worst of it already, though it's still expected to hang around to some degree. Certainly no sign of westerly anomalies there. That would put a damper on storm development, most certainly. And from this chart, it looks like the inactive phase of the MJO is in control. Now, this is what's really interesting. Here's another set of models, and what they're showing is the polar opposite of that. That is, this is outgoing long-wave radiation, amount of sunlight reflected off the ocean surface. If you got blues here, they're negative numbers. That suggests more cloudiness. That suggests the active phase of the MJO. Yellows suggest the inactive phase of the MJO. But the Kelvin wave generation area is right here, and we see, per the statistic model, looks like the active phase of the MJO is trying to get control, and per this, for the next 2 weeks, it's supposed to stay in control. The GEFS model also suggests the same thing, though not as strong. Actually, this was suggesting even less of these blues 2 days ago, and so it's starting to come on, get in sync with the statistic model, suggesting whatever easterly anomalies we have may be short-lived. And yet, another way to look at this, these are what they call phase diagram charts. The big dot right there and there suggests where the active phase of the MJO is. Over the maritime continent, that would be New Guinea area, far, far west Pacific, if you want to call it that. Okay, the MJO travels counterclockwise along this chart. The further away from the circle, the stronger it is. That's not very far away from the circle, suggesting a pretty weak active phase at best. Anyway, the MJO travels from the maritime continent over the dateline, over the West Pacific, over the U.S., into the Atlantic, over Africa, back to the Indian Ocean. It just sort of does this circle around in about probably an 8-week total circle for the active phase of the MJO. So for relative to the Pacific, 4 weeks active, followed by 4 weeks inactive. Anyway, the ECMF model suggests weak active phase over the maritime continent. The GEFS model suggests the same thing. The forecast is the green line. Now, this model suggests some weak active phase making its way east into the West Pacific. The GEFS suggests a collapse into nothingness in about 5 days. So a little bit of a spread there. Let's go take a look at one other model. So here we go, the CFS model, again, up at 850 millibars, about 4,000 feet. Kelvin wave generation area is, here we go, maybe we can just pop, here you go. There's the date line right there. Now this chart, past history is down here. The future is up here. Kelvin wave generation area, 180 to about 135, or 170, sorry, to 135. So draw straight up here. So roughly in this area. Here is that patch of easterly anomalies that the previous models suggested. It's on this model as well. And here is what's going on. This is the models. The dash contour lines suggest the inactive phase of the MJO, and if it is, it's very weak. Now, the interesting part is, as you go into the future, look at this. There's just no discernible MJO forecast until November or so, till we get officially into fall. So just a weak, nondescript pattern. The good news is, whatever these easterly anomalies are, they're supposed to move off to the east. Weak westerly anomalies forecast to move more over the Kelvin wave generation area, but again, very weak. And then the model has been always hinting now for like a month that some strong MJO pattern and westerly anomalies are going to develop over the Kelvin wave generation area. Always about 2 months out, and you get to that 2-month spot, it doesn't materialize. Our thought is we're just in this kind of dead neutral place where the MJO just isn't strong one way or the other. It doesn't provide fuel to the jet stream, and that doesn't really help support storm formation. That suggests a rather weak storm pattern for the coming months. So the thought is, and we generally tend to favor this model. This seems to be the most accurate long-range model of any of them. So the strategy would be, if that's the case, if you see swell, if you got swell, there's swell on the charts, make the most of it. Do not blow it off and say, oh, I'll wait for the next swell because it might not come. These weak kind of patterns, this is the way the game is played. You get what you can. Also, one point of interest here, the low-pass filter, this in the East Pacific, this was the indicator of El Nino. Now notice here that it moves into the Indian Ocean. That's pretty typical of La Nina. That's where all the energy moves, is into the Indian Ocean. So we've talked about the MJO and the propensity for it to happen or not. Now let's look at the effects of El Nino and subsurface water temperatures. That sort of gives us another dimension of what's happening in the oceans. Right now, actual water temperatures, all the warm water here pooled up in the West Pacific, pretty much typical of La Nina. Notice a rather steep line right here, the 28-degree isotherm separating warm water from cooler water to the east. This isotherm here suggesting that whatever warm water there is in the east, it's very shallow and very limited and retracting off to the west. That's pretty much typical of La Nina, and that is normal post a strong El Nino. Water temperature anomalies, differences in normal for this time of year. Again, this is the West Pacific here, East Pacific here. We're at depth, down 200 meters or so. Here are the actual anchor lines on the buoys strung across the Pacific. There's sensors where each of the X's are, so that tells you how many data points you have. And you can see, if you've been following this chart has actually improved significantly. We had a major incursion of cool water the whole way across here, and we still do, as you can see, but it's much warmer than it was. It was down -3 or 4 degrees. Now we're just down like -1 degree, and what's working its way up to the surface, basically south of Hawaii here, is a ½ degree, if something like that. Not very much of a La Nina, a very anemic La Nina at best. The high-res subsurface picture, basically the same as the others, suggesting a little bit more cooler water than the other image suggested, but still not robustly so, just kind of it's La Nina, but just barely so. And then we start looking at actual sea surface anomaly data. Typically, if you're in a robust La Nina, you'd see a lot of upwelling here along Peru. What do we see? No, warmer than normal water. The reds are warmer than normal. A little bit of cool just here between the Galapagos and Ecuador, but also equal parts warm pockets. Then as you move off from the Galapagos, yeah, there's a couple of cool pockets, but really nothing. You don't get your actual cooling until you're out about 120. This would be south of 120 west, be south of California, and out from there. So that's where the heart of your La Nina cool pool is. The trend for the past 7 days, well, here you go, right along Peru, pretty much neutral. Not a whole lot going on. A little bit of warming here from the Galapagos out to almost that point again, south of California. Then equal pockets of cooling and warming out to the date line. Not a big push one way or the other. We did notice a little bit of warming here going on off of Africa. Sometimes what happens over here also materializes here, and that seems to be the case. There was cooler water in this area, and there's been this steady kind of warming going on. I mean, certainly not an El Nino warming, but just sort of a return to normal. And we'll take one more picture here. This kind of pulls it all together. So if we were in La Nina, you'd be expected to see all kinds of cool water here and off in here. You don't see any of that. If anything, you see normal to slightly warmer temperatures here, and your cool pool is way out here. So we've talked about Modoki El Ninos in the past. That is a El Nino, but not really. And what they tend to be is westward displaced. Another way to call them is a Central Pacific El Nino. Well, what we appear to have is a Nino La Nina. Westward displaced, no immediate impact along the Central American coast. It's all south of Hawaii and not particularly impressive at all. This is actually good news. A Nino La Nina following a strong El Nino is exactly what we would want. Otherwise, what normally happens is you have a strong La Nina, and you have cold water all over here, and what that does is that supports high-pressure loft. It really supports the inactive phase of the MJO. That stomps on storm production, and you get into winter, and it's just, cold, windy, no real swells, and then when a swell or a storm does form, it lasts for a day or two. You get maybe a one-day swell out of it, and then you're back to misery. So this, not great for storm production, but certainly a lot better than the alternatives. We'll take it any day of the week, especially when this is the manifestation of La Nina as a bounce back from a strong El Nino. This is the best possible scenario. So we've talked about the MJO, or lack of it. We've talked about El Nino or La Nina and the Nino version of it, which appears to be in play right now, which is a weak La Nina. So let's go see what effect that whole thing has on the atmosphere. So we look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Negative numbers suggest the active phase of the MJO. Positive numbers suggest the inactive phase of the MJO. That certainly appears to be the case. Current data, plus 14.14. The 30-day running average, this sort of gives you a trend of what's going on. You can kind of look here. It was a month ago 3.67. Now we're up to 12. That suggests certainly the inactive phase of the MJO. And then the 90-day running average gives you sort of a sense of what's going on. If you had negative numbers here, it would be El Nino. Positive numbers suggest La Nina. And we're at 6.14, which isn't very positive. If we were up at 18, 20, 25, then I'd be, we'd start going, oh, La Nina is stronger than it looks, but this data suggests not very strong. Another way to look at this is the ESPI index, very much like the Southern Oscillation Index, only its differences rather than temperature, or pressure, it's differences in precipitation between this area north of Darwin and this area north of Tahiti. Positive numbers suggest a El Nino kind of pattern. Negative numbers suggest La Nina. We have negative numbers, minus 1.05. Yeah, it was actually down to minus 1.5 a little while ago. It's been softening up, and that's sort of what's happening with this whole La Nina. It was starting to come on, looking semi-strong, and then it's just been steadily getting weaker and weaker as we get into the season when it should be getting stronger and stronger. So again, this is more good news. Then finally, the forecast for the Nino 3.4 region. This is the main area for measuring El Nino, La Nina, and this is roughly from 120 west out to 170 west, 5 degrees north and south of the equator. Here's what temperatures were at the peak of our El Nino back October last year or so, almost 3 degrees above normal. As we've worked our way into the spring and into the summer, temperatures fell negative, and we thought they were going to go much more negative, down like in the minus 1.5 region. But this model now suggests, well, we maybe will dip down to minus 0.7 in now, basically, so the September time frame. And from here on out, it either sort of ticks along about minus 0.6, minus 0.7, and then works its way positive after we get pretty much into February, somewhere in the summer, back to positive. So if this is the sum total of our La Nina, you got to be at a minus 0.5 to even be La Nina, and it has to be for 3 months, 3 consecutive 3 months periods in a row, and we're barely going to make that. And officially, NOAA is not even calling this a La Nina now. They're just calling it cooler than normal temperatures, but not a full-blown La Nina, which is a good thing. And all the data suggests that if this is we're almost in the worst of it right now. In fact, here is a summation of all the models. Notice here, all the different dynamic models for measuring El Nino, La Nina, all the statistic models, all on one chart. And they're all sort of saying the same thing, that, well, here's our temperatures, we're at minus 0.5. And it just sort of is to track, if you sort of look, the dark lines are the yellows and the, I guess that's sort of that color, and we're looking for that and that. They're all kind of just cruising along right in here at minus 0.5 into the December, January time frame. And then temperatures start creeping up and almost normal. We can actually go down here and look, and we're not going to get into tearing apart each one of these individual models, but here's the average of all models, actual numbers. You go minus 6, that's where we are today, maybe down to another minus 6 reading, what's that, November time frame. And then after that, we start creeping up towards neutral. So if this is our La Nina, I'll take it. I'll be happy for it and say, yeah, if that's the worst of it, that's not too bad. Bring it on. That's a small price to pay. We knew this winter wasn't going to be anything, spectacular. The thought was La Nina was going to be much stronger than it now appears to be shaping up. And all the model runs are saying it's falling apart. That is good news. So to put a bow on things for this evening, basically a little bit of swell in the water for California, nothing too impressive, but a little bit of North Pacific swell. Fun, it's rideable. And then Southern Hemi swell for later in the week, into the weekend. So more swell to ride. The charts, not inspiring, nothing significant either in the North or South Pacific, but we'll see. Maybe things will change. It looks, though, like the inactive phase of the MJO is somewhat in control, no matter what the charts and the models say. They just, with those easterly anomalies in the Kelvin wave generation area, suggest some non-supportive atmospheric feature for storm development, at least for the next week, but then maybe it'll be over. Long-term outlook, La Nina, yeah, it's there. Vidoe La Nina, if anything. Weak, westward displaced. I think we might get off kind of easy this winter. That's good news. That's also a good suggestion that the active phase of the PDO is taking over. We've talked about this every week. 15 to 25 year pattern. If the PDO is turning active, that would be a perfect explanation to why La Nina is not developing as strong as forecast. And that suggests that the atmosphere is in fact biased towards the formation of La Nina, and that suggests more storms long term. Maybe not this year, but maybe next year or the year after, and we might be into a 15-plus year run of good surf. We'll see. We'll remain optimistic. So that's it for this week. Go get some surf. Have a good time. We'll do it again next week. Same time, same channel. Thanks.